Welcome back. This is Mr. Greenstein's Geometry, and we're in Chapter 11, Section 3. We're talking about areas of polygons. We just finished talking about kites and rhombuses. Now let's talk about the regular polygon. Here I have a regular polygon. It's six-sided, so it's a hexagon, and I draw a circle that circumscribes around this regular polygon, so it hits all of the vertices. The center of a regular polygon is the center of the circumscribed circle. So on a regular polygon, this is the center. Notice that each one of these radii out to the vertices is going to be exactly the same. The radius is the distance from the center to a vertex. The apothem is going to be from the center to one of the sides of the regular polygon. Remember, whenever we talk about a distance, we're talking about a perpendicular distance. And the central angle is going to be the angle formed by two consecutive radii. So the central angle is this angle here. And we know something about the central angle because if we know that this is 360 degrees all the way around, then 1/6 of 360 degrees is going to be the central angle for this particular polygon. So let's take a look at this triangle. We have a pentagon, a regular pentagon, and a circumscribed circle around this pentagon. Then what is special about this triangle? Well, what is special about it is that it's isosceles. Yes, Mr. Greenstein's favorite, because it has radius here and a radius here. They're the same length, so then it's a isosceles triangle. So to solve for these angles is pretty straightforward. First of all, let's just take a look at the central angle, which is here. The central angle is going to be 1/5 of 360 degrees. So if I take 360 and divide by 5, I get 72 degrees. So that's the central angle. Since this is an isosceles triangle, and I draw this apothem, the apothem is going to split this angle, central angle, into two. Therefore, each one of these little angles here is going to be 36 degrees. And then the base angles of the isosceles triangle are going to be equal. And since this takes up 72 degrees, then I know that each one of these base angles is going to be 54 degrees. In answering the question AFB and AFG and GAF, I'll let you come up with the answers to those. Now let's talk about the area of a regular polygon. The area of one triangle. So let's say that we can calculate one triangle if we know the apothem, and we know the side length, then we have the base and we have the height. So we can compute this triangle's area. And then each one of these triangles is congruent. Therefore, we just multiply by the number of triangles to get the total area. So here I have 1/2 S times A, the side times the apothem, and that's this one triangle, times N, which is the number of sides or the number of triangles that I have. So the area of a regular polygon is 1/2 times the apothem times N, which is the number of sides, times S, which is a side. Another way that we could say N times S is the perimeter of the regular polygons. So if we added up all these sides, that would be P. 1/2 apothem times perimeter. So let's calculate the area. In this particular case, the apothem is 8. We also know that this is an isosceles triangle, and using a little bit of trigonometry, we can come up with what the side length is, S, because this is a right triangle. So I'll let you compute that. The same thing for part B is that if I draw the triangle to the center and then draw the apothem, then you can do a little bit of trigonometry to come up with what the apothem length would be. And once you do that, then you can calculate the area using this formula. So I'll let you compute that, and we'll discuss this in the next time we get together.